we're going to talk about section 14 to what's it called? It's kind of like more a review on SQL. You'll notice that the section for section 14 on the curriculum is relatively small. It's mostly to test your knowledge, kind of do some checks and stuff like that. I think there's a built-in quiz. Note that I'm not like grading that or anything weird like that. It's more like for your own self-check knowledge. So if you like find yourself really stuck on it, basically just know those are the parts that you need to practice more. Okay. So cool. Now I will tell you, I'm a little bit ambitious today of all the things I want to complete. So in reality, I don't know if we'll actually get to everything, but we'll see. Okay. So I'm gonna go start sharing my screen and we'll get right into it. And while I'm sharing my screen, looking for the right one, remember that we talked about SQL back in section 9, which I realize is the beginning of the module that we're close to finishing now. We only have a couple more sections really of this module before we finish. And of course, where did you guys go? Sorry, my little window. I need to look at that. Oh, see, it's in a different spot. I don't know why. Okay, it just changes every different place. Okay, I need to look at that later. But anyway, so we talked about, if you remember back when we did co-teaching with Jeff, so we actually went over this part just to kind of quickly review parts of it. I'm not gonna like go through the actual code and everything. We introduced what SQL is itself. So if you remember, here we are, intro to SQL. Right here, we talked about what is SQL. We talked about database structure, a schema. So we'll actually still use the schema mostly today, but we'll also talk about some extra stuff too. We talked about SQL being like really versatile, well used in the community. Data science, it's kind of like one of those things like I see polls all the time. It's like, what's the most common skill that you need to do in your everyday data science life? And everyone says SQL because you're basically getting data all the time. And so many places just are compatible in SQL in so many ways. So the more practice you get with SQL, the better. Okay. So from here, we actually went into our little lesson with Jeff. You guys remember Jeff? And we went through basically just showing you how to use SQLite 3. And then kind of tying it in with pandas and stuff like that. So remember, we had to do this kind of funkiness with the connection and the cursor. I know this can be kind of like a little mind bending and stuff, but just remember the connection is saying you're connecting to a database. This connection, in this case, is actually a separate file. It's actually on my computer right now. So I don't have to like go through the network and stuff like that. But sometimes you would go into the network either from through the internet or through the intranet. So maybe like a local system. So maybe there's a server like where you're working and you might connect to it in a certain way. And of course that could be different things. It could be a MySQL server. It could be a PostgreSQL server. It could be DB2, which is not as common, but like you can see all those different servers and they all have their separate protocols and exactly how you'd put this though. But essentially we connect to that. And then our cursor, like I think I talked about it, it's kind of like your little messenger person. Essentially, they're the ones who kind of getting the message back, the information back and forth from the SQL server itself. We kind of showed just again how to like get all the tables with this query, which is super useful. So usually this is a nice thing to know if you've never seen a database before. Hopefully the schema is actually up to date, or I should say the ERD, the kind of printout. In reality, there's a pretty good chance that they're not up to date. That's pretty common. So just kind of be aware. So this is also a good check to go through. We talked about the different table names. We showed basically how to get a query using a query from fetch all and stuff like that fun thing. We can see it's kind of this extra mess of like list of tuples, which is like, it's fine, but like, it's not pretty. Like we want it nice and pretty and easy to form like with a data frame. So I showed you how we can actually create basically a function. Oops, mouse going on everywhere today. Function right here. So basically I created a function to get all the information into a little bit more order. And then you can actually, I think a little bit later on here, I make another function so we can actually pass into a data frame with all these nice column names. So this is something more familiar about. I mentioned about not loading directly into a data frame usually. Usually you want to know how much data you're going to get beforehand. For example, if you're going to get like huge amounts of data, you won't want to put that in a pandas data frame because maybe overload your system. But for this case, like I know this database is really small, so we're just going to kind of use this function over and over again. Okay. And then of course we did some little practice and everything from there about getting specific results and using aliases and all that. Cool. Sound good? That was a really quick, like hopefully less than 5-minute review of like what we talked about. Cool. All right. So I'm going to go through a few parts. So we're going to talk about actually creating a table because we kind of skipped over that part. In reality, you don't create tables too often because obviously you create a table and then like it's there. So a lot of times, like, I think like I created like maybe 2 tables and all of them using like SQL with another enterprise, just because you're just likely not going to be doing it yourself. It's usually set in stone, but you might need to do that. And then we'll talk about some joins and say like different joins and different aggregation functions. I will not go into complete detail. I think honestly, the best thing to do is just practice rather than me talk about it, and kind of play around with it and see if you can mess around. And the last part, which is this little advanced tab here, that will be talking about a few extra stuff that we can do to kind of like kind of some more practice and stuff like that, and maybe talk about execution and the query plan for a server. Okay, sound good? Cool. And real quick, this advanced part, I did not have that uploaded to the repo that I normally show. And I just realized, Serena, since you're not usually with our cohort, this stuff can be found in this repo. I think it's under data engineering technically. So I think it should look something like data engineering SQL under the repo. And these are the different files. Right now, the advanced part is not uploaded, but I'll hopefully upload that today. Okay, cool. So we'll dive right in then. Sound good? All right. So like I said, we're going to basically start using some SQL and see what is going through here. So we have pandas, NumPy. I don't actually think I used NumPy, but I imported it anyway. SQLite 3. So we're going to create some tables. So you might want to create a table for basically like you're going to use it later on. This is most us playing around with a little bit. So note that this isn't exactly right. Note that this right here, this connection, SQL connect, and planets.db. So this is going to be a database. This is just basically a file essentially. And then you can see the cursor connection. Note that you can put whatever you want here. And however, look at my part right here, you'll see, let's go ahead and get rid of this part just to make sure it's not there. You can see that there's no file called planets.db. So basically what this is going to do when I do using SQL, okay? When I use this and I'm going to create this, this is actually going to create a file, planets.db. Now note when I run this at first, I don't believe it creates a file at first. Oh no, I'm wrong. Okay, it makes an empty database. So you can see 0 bytes. So there's nothing being used in there. All that stuff. It's basically, it's a database ready to go. So just know that's a separate file. Okay, and now I'm going to actually start creating stuff in that table itself. So again, this is, to be quite honest, if I do this, I usually like look it up because I can't remember how to create tables exactly every single time. So I mostly look it up because it's just not a very common thing that I would do. So note that's perfectly fine. So note that I have the cursor.execute. So I'm going to execute this query. I don't really care about the output necessarily. I just kind of have it say, go ahead, server, execute this part. We have create table. Remember that in SQL, we don't really care about capitals or lowercase. It doesn't really matter. But I try to keep things capital that are like built into SQL. That way you know like this is specific. So I'm creating a table called planets. And then you have to basically pass in the information about what planet's going to have. So in this case, there's going to be an ID, a name, color, number of moons, and mass, right? And you can see here, I have to also pass in what type it is. So you can see here's integer, text, integer, real. I believe you can also pass in Booleans, and maybe I'm wrong about Booleans, but I know you can pass in blob, which is basically a binary file. Usually they're used for like images and stuff like that, but I'm gonna ignore that. I actually don't think if you can put, does anyone remember if you can put Booleans within SQLite 3? Yeah, everyone's got something different. So you just look it up. I think it talks about in the curriculum. So again, perfectly fine to look things up. All right, and then note that I make a primary key. This is going to be required for us to actually do anything off of this. So you'd have to define this as a primary key. There are other ways to define primary keys, which I think I might show a little bit later. But note that usually you would use one as, you would try by convention using one specific column to be the ID. You can technically use multiple columns to be a primary key, but it's not considered as good practice, though you'll see it. You'll see it sometimes, especially like startups who are just kind of like trying to scramble to get things to work. Okay, so this right here, real exciting, created a database, or not database, a table within a database. And now you should see we actually have some information in here. One thing to note is that if I tried opening up this file, like trying to edit it, you're not gonna be able to see anything like interesting, like it's gonna be all gobbledygook, because basically it's optimized to be searched over. So note that you can't just open up the file like a CSV file and start editing parts or look at it. You're gonna have to use SQLite 3 or whatever thing to interact with that database. So just know that it's not worth trying to open it up. And then you'll probably try to open it up and it'll say, oh, you don't have the right encoding, because basically it's a bunch of gobbledygook. Okay, so we got to create our database or our table. Now we actually want to put stuff in there. So now we can actually change up our table. So let's say it's like, oh shoot, I forgot to add in rings. I wanted to put that about planets. So I can actually alter the table, planets, so that's the table itself. I can add a column called rings, and then, I could put in booleans, and I can put in a boolean. Okay, so this basically will alter that table as if I put in column rings right here. So now that's going to be altering it. If I already had data within that table, right now it's blank, but if I had data in there, what would come up, you guys think, on the, if I added the rings column? What do you think would happen to the rest of the data if I had like a bunch of rows already in there? You got to guess? Yeah, it'd probably be like null values, right? Some equivalent to like none and stuff like that. So note that that happens. So if you do modify a table, be aware of that if there needs to be a default or there needs to be backlog afterwards. Okay.
Well,
So now
there would
yeah,
only be null for that column, right?
that's right. Yeah.
Okay.
So rings would be not null, but everything else should stay the same.
Stay the same. Okay.
You can also, I know you can add defaults. I don't know how to do that specifically because I'd have to look it up because I rarely do this kind of thing. So just kind of be aware. Okay, cool. So let's insert some data into the table. So this is actually something that is relatively common, but you probably won't like to do it over and over like this. You probably will write a function or some automated process to insert information, but this would be the SQL way to do it. So what we're doing here, we're inserting into, so basically we're telling SQL, hey, we're going to do an insert. So we're insert into planets, so that's the table. Note one thing is that I kind of tab these. This is not needed. It's just that I like to read it this way. You might see it all in one line. You might see a different tab. Just know it's the same thing because SQL doesn't care about white space. But I'm inserting into planets. And note that this right here are the names of the different variable or of the different columns. So you can see here name, color, num, moons, mass, rings, which is not this. I don't think it's the same order. Maybe it is the same order. Mass, rings. No, okay, it is a different order. It's a slightly different order, right? Oh, no, it's the same order, whatever. But you could mix them around. So you don't have to necessarily put in the order that the table is structured. And then basically within this other tuple, I have different values. So each one of these values will be a separate row. So you can see here, I made up some values, just if any astrophysicists end up seeing this, right? So Mercury, Venus, Earth, Mars, Jupiter, all the way to Pluto. I include Pluto, not because I believe it's a planet, just because it's just a nice number, right? So yes, I am that person. It is not a planet. Okay, so you can see some values going forward. You can see rings. Again, I made up some numbers and stuff like that. I know Saturn has more than one ring. So anyway, we run this and basically we insert it in there. So cool. And we go back to actual row database. We can see it's a little bit bigger. I think before it was like 4, I think. Or sorry, 1 kilobyte something or something along those lines. Oh, sorry, here it is. Oh, maybe it's bigger than that. Oh, I'm sorry. This is fun. So what is this part? This guy right here is basically we haven't we executed, but we haven't committed to it. So basically the cursor is like getting like, all right, here, I'm ready to kind of execute this through, and it's going to push it through. So that's why you might see this journaling part. Okay. So as we basically execute more and more functions or queries, that will be put into the database. Okay. And it's trying to optimize it. That's the real reason why. Okay, cool. So we inserted stuff into the database. Cool. So let's go ahead and try to make a new table. So in this case, you can see something similar. I created exoplanets, kind of similar stuff. Okay, in this case, I put a star, like what star it's orbiting, right? So I'm going to run this guy. This is getting a new table now. I can execute and alter that table just like before. Okay, so kind of the same stuff. And then I can insert into this table. And again, I just give its variable names as well as the values that will actually go through here. And again, these are all made up exoplanets. So let's put them in there. Okay. So that's kind of how you would basically create a table and then actually insert information. So essentially what we did last time, we mostly explored the data set and then looked at that. This is more like talking about how you would put information into that database. Any questions? No, sound pretty good? Okay, all right, cool. So I'll kind of briefly go over some parts of exploring just to kind of show us that we can actually pull this information out. This is stuff we've seen before. So note this is all one query. Select name from SQLite master. This is just saying which all the tables are. So we should see planets and exoplanets, right? And sure enough, that's what we see. So these are just listing all the tables. And so let's go ahead and do an actual query, a SQL query. We can say select planet names. So remember, we can specify what what column we want or what columns. We could say from what table, and we get basically all the planet names. Okay, we can do something similar with select star from exoplanets, where we'll get all the data. And note that this is not my nice little data frame function. So note that I don't get the column names by default. I have to know what it's implied by. But note that also the ID is automatically given because it's my primary key. It'll just keep adding 1 to it. If I deleted a value and I inserted a new one, let's say I deleted, DSFA. I made it up, right? So let's say I deleted this off the table, okay, and I inserted a new exoplanet. What do you think the ID after that would be? Any guesses? There's 2 obvious ones, but only one of them's right. So I see 5 for ID. What would be the other one that I'd say, like the quote unquote obvious one? 3, right? Okay, thank you, Jenny. So yeah, you might think like, oh, maybe it's like reusing the IDs, right? If you remove an ID, maybe it goes there. It actually will just go to 5. It'll just keep counting down. And one of the reasons why it does that is that if there are other parts of the database that refer to that ID number, well, you want to make sure you don't have that crossover and stuff like that. So basically it knows if I just keep adding 1, it's going to be a unique ID for that specific row. So this is again, an important aspect to just remember is that you might have spaces between IDs and stuff. Okay. And then you can see here, this is just showing the different names. Okay, cool. So I'm going to kind of skip over this part. You guys seen these functions before I wrote. Basically, they're just so I can make it a little bit easier for us to get the columns and names all together. More exploration. We've seen these parts. I'm not going to kind of go over it because we've seen how to reiterate these parts. Let's see here. So let's see here. If I want to do this part, I think there's one part in the bottom here. Yes, so this is what we're going to talk about. This is new. So just kind of know this part right here. I'm just going to, did I make a function? No, pass vector is not good enough to make a good function. That's okay. I'm just making sure I run this part so then if there's anything in the future. This was a old lesson that I had put together before I did one with Jeff. So that's why I'm running these parts. Okay, so one thing we can do is I talked about when you do SQL, you're basically telling the server, hey, do this for me, okay? And so SQL can actually be really nice in this way because instead of like getting like say, hey, SQL server, give me all the data. Well, some issues with that is that 1, your computer might not be able to handle all that data. And 2, it might actually take a while for that data to actually come over to your computer, and then your computer has to do all the work of sorting it through. So if we know specifically what we want from the server, we can say, hey, server, you do this work, so that way it's a little more efficient, and then pass me that information. So one thing, for example, we'll talk about like aggregation. So if you wanted to count, how many times something occurs, well, one way you could do that is get all of the data, get into a data frame, and then count out where everything occurs, and then that would be your result. And all you care about is that result. But the problem is if your data is very, very large, right? There's a huge amount of data. Well, now you have to get all this data just so you can get basically a summary, where maybe you can get SQL to do it, or your server say, hey, server, do this stuff for me, aggregate for it, and then pass it over. And what's nice about that, usually the server is optimized for those kind of queries where basically it knows where the data is already, or actually the data are already. And so it can figure that part out and usually can do a little bit quicker than what your computer can do too, especially if there's a lot of data that you can't handle directly. And what's nice about this, because remember SQL is very versatile, this can be really useful if you have something that's not like a traditional database, like a not relational database that we'll talk about next time. There's a lot of times SQL interfaces. So you can say, do this thing for me, but in reality, it's maybe talking about different nodes and stuff and doing some complex stuff that would take you a lot of effort to do on your side. But instead, basically, it's all done in the back, like basically out of sight, does it for you, and then you can get that information to you. Okay, and that's closer to like what data engineering would do, but then we can get that information. So first one's aggregation. So I'm going to show you aggregating moons. So let's say we want to count how many moons there are of certain colors and stuff like that. Or I think we'll see what it is. So one thing, let's see here. Let's say I want to see how many moons there are, right? So you can see here, I could do like the pandas way, which is basically get all the data, right? And that's what this part right here. So I can get all of the data, and you can see here, these are the different moons. Okay, and then I might want to do something moons aggregate df.moons.value counts, and I can get basically all of these moons right here. Okay, So this is kind of like you would basically, the whole idea is like you would input all of it and then do some pandas functions on your data frame to get this information. Another way I can do this, oh, I'm sorry, I should slow down a little bit. What I'm doing here is saying how many planets have this many moons. So 2 planets have 0 moons, 2 planets have 2 moons, 1 planet has 1 moon, and then you can see 1 planet has 14 moons and so on. That's what this is saying, is that there's 2, for 2 moons, there are 2 planets. For the number of the planets that have 0 moons, there are 2 of them. And then the number of 14 moons, there's only 1 of them. So basically I'm using this to say, okay, how many are these values? So you can kind of see, like, if this was a very long list, we'd have to have this huge value, but maybe you'd have a very short list at the very end here, right? So maybe it's like, there's like 50,000 different planets that you're looking at. And you want to see, you know, what's the distribution of these different moons. Well, this would take a lot of work basically just to get that in a data frame, and then you have your computer crunch it. So another way you could do this is the SQL way. So note that our SQL before was just get all the data from planets, and then we'll hand it ourselves. Here we ask SQL, say, all right, select the number of moons. So we're gonna know how many moons there are. So if there are 0 moons, 1 moons, 2 moons, 14 moons, right? And then we want to say, okay, count star as planets count. So this is going to count how many values occur for that moons. And this goes from the fact that we do a group by. So have we seen group by before? Okay, I see some nods. I think in the curriculum it's mentioned. Okay, good. So just know this group by here is saying, all right, we're taking that column and we're just going to group them that are similar things. So it's going to group all the ones with 0, all the ones with 2, all the ones with 1, which is going to be one of them. And then it's just going to count right here. And it's going to display as planets count. So what's nice about this gives us essentially the same result as this one right here. You can see that the number of 0 moons is 2, number of 1 moons is 1, number of 2 moons is 2. And if you order this the right way, you would see the same exact values, right? So what's nice about this is that this is going to occur on the SQL server, while this over here has to be done on, like, basically on your local machine in Pandas. So this can have some huge advantages where if this data set is very, very large, have the SQL server do something, and then you can even have your computer do multiple parts. Or if you have multiple servers, you can say, okay, you do this thing, you do that thing, you do this thing, and basically you can wait for that stuff. Versus if you had to collect all this data, do it yourself, it's going to take more time. Does that make sense to people? Thumbs up if that's good. Okay, cool. All right. So I know moons probably was not probably the best thing to aggregate, but it's the only thing that I really had down here. So something similar, we can actually filter for colors, right? So in this case, I'm going to just see how many different planets there are with different colors. So we can do it the Pandas way, which we basically get all the data, right? So we get all the data like before, and you see that this takes some time, right? 15 milliseconds. Right, to do all of this part. And then only blue planets. So let's say I only want to get the planets that have the word blue in it. So you can see here, I want to count light blue, dark blue, not brown, but we also want to include blue. So you can see here, I basically do some pandas in here. I take the data frame and getting the color, which is this column right here. Okay, and if the string contains blue, that is going to be true, right? So this will basically, this is my mask to say, get only these rows that have this part. And then I'm going to get from here, I'm actually going to get all of those rows, but they have, get the name and the color. So I'm going to say what name is it and then what color is it. So this should show me Earth blue, Uranus light blue, Neptune dark blue. Okay. So cool. But you can see, you know, it might be a little more work on this. You might feel comfortable and do fine on here. But if there's, again, a very large data set, well, let's say I have like 50,000 planets, but like 10 of them are blue. Well, now I have to get all 50,000 planets, then find the ones that are blue. Where if we have the SQL, we can basically say, all right, get me these specific planets and say where the planets.color is like blue. So this where right here statement is going to basically filter out which rows we're actually going to get back. And so we can actually say this is kind of like a conditional. You can imagine this is like where this reads kind of like English, right? So lower basically is a function built into SQL that will basically change whatever this is down here to lowercase, just in case there's some capital letter. This actually wouldn't be needed in this case, but it's good to do this, okay? And I have it like, meaning that's kind of like it's equal to, but in a sense like it's equal to, but only parts of it. And then you'll see this parentheses signs right here. This is saying, you know, like I don't care what's on the left, I don't care what's on the right. So I could have, for example, say it ends with blue, right? And this basically said, if it starts with something, something, something blue, I want that. In this case, just to make sure I got everything, in this case, again, it wouldn't matter. But if there was something like blue, green, this would count right here because that would actually say blue, and then I don't care what's on the right. So that's kind of like what that little difference is. But anyway, I have my SQL command. I can run this now, and you can see here, I now get the same exact results. Okay. So again, there's just two different ways. To be honest, sometimes this is just easier because you might be more familiar with Python and it will go through. But sometimes this can be a lot faster, and a lot faster can be like, sometimes minutes or, possibly like even longer, depending how big the data set is and what kind of computer you're using. Remember, Pandas has to load everything into memory. So if you have a lot of information in a data frame, it's going to take up memory space on like in the RAM on your computer. So if you have a relatively small computer, even like 128 gigabyte, RAM, at a certain point you'll probably run out. Where a server can usually be configured to do this more optimally, and you don't have to worry about those limits as much. Okay. Any questions on how we this difference between SQL and Pandas or anything like that? Cool. Right. So we saw some aggregation. Yeah.
I just had a quick question about, so once you get it from SQL, then could we pipe it to Pandas just the way that we did before, or once you get, so that we can get it into our own computer and do more with it. Let's say if we just wanted, I know this is a small example, but
yeah, you might want to do that too. Depending on your use case, you might say, oh, I don't want just this. I might actually want more of the database, right? Or sorry, more of the table. And so you might actually say, okay, maybe do a query that's going to filter some parts out, and then you're going to do the rest in Pandas. That's, that's perfectly, I would say like that's pretty common too.
Okay.
Cool. Awesome. Yeah. There are some people who do like almost like will always go SQL more than Pandas. I am not that person. So just kind of know that everyone has their preference, and sometimes it's speed, but sometimes it's just like usability. If it's going to take you like half an hour to write the same query that it would take you like 5 minutes to do, and it's not going to be that much speed difference, you might as well do the thing that's going to take you 5 minutes. Okay, cool. All right, so we'll move on then to some joins. So here's some more parts in here. Again, this is kind of from an earlier lesson, so I'll be a little fuzzy on it, on the exact details of like how it flows through. So just kind of forgive me if I take a little time, like, what was I doing here? So we'll see. All right. So we're going to talk about some joins and stuff like this, and there's going to be two main joins, but we're going to talk about this order database, which we had before, with I think it's the employees, customers, order details and stuff, right? I'm going to import these functions that I've had before. So just know that this basically will get our columns, if you guys remember, and then really I just want to make a nice data frame so I don't have to do it. This is not the best practice, I will tell you this. There's other ways you can do this as well, but I'm kind of showing you a little more cumbersome part because I kind of want you guys to work a little bit harder for this one, because you don't want to just load it directly, a query directly into your data frame, usually. So because it might be too big. Okay, so we'll go ahead and start getting from the order details just to show you what this looks like. So we'll go ahead and write a data frame from here. And you can see here, order number, product number, quantity ordered, price each, and ordered line number. So that's kind of the stuff we'll look at. We can also see like how many values there are. You can see there's almost 3,000 values, so 3,000 different orders. And then we can get some extra information if we want to care. Like for example, quantity ordered, maybe you wanted to see like the frequency if this is going through and stuff like that. Okay, so we have our order details, we have our products. So we'll see what this looks like real quickly. And you can see here for products, we have the product code itself, and you can see there's quite a lot of products probably, and the different product names, product line, all the way to the buy price, MSRP. So you can see there's a list of products. This is completely separate from the orders. And if I look at this, it's probably going to be a decent sized number of, oh, actually it's not that many, 110. So it's 110 different products. So what I want to do here is I want to merge this. Like for example, if I have an order, I want to know, like you can see there's a product code here. Here it is. There's a product code right here. I want to know, well, what is this product? Like what's that name? Maybe I want it to show up on, in my actual visualization. Maybe if this is making something for a customer, you'd want to be able to put this into the receipt or something like that. Pulling it from a database, you want to be able to combine these parts together. There's a lot of reasons why you'd want this product code to actually have more information just than the code, right? So we can combine this with part. And that's where joins come in. So at this point, we've seen like, I think we talked about joins, but we haven't talked about it explicitly. So this will be kind of review, maybe a little bit of more detail. So the first most common one is an inner join. In fact, it's the default join for SQL. So what inner join basically does, it's going to say whatever's on this side and whatever's with this side, when we combine together, only keep that intersection. So if there's some information missing from order details, or if there's some missing information from products, it's not going to be combined in that intersection. So for example, if there is an order that uses a product number that does not exist in the product database for some reason, that order will disappear from the result. So just kind of be aware of that. So that could be a problem in the sense that it's not going to show up as none. It's just not going to be included in the result. The other way it goes too, which is probably more what we care about, or not care about, but like what we'd expect, is that if we have orders, right, and the products, we have 110 products, well, if an order doesn't use one of those products, it's not going to show up in our results, which is what we want. We don't want that extra information, right? Because it's not in part of the order. So just kind of know that it goes back and forth a little bit here. And that's what an inner join is. Basically, it only looks at like the inner part of that intersection. Think of like a Venn diagram. That's usually how it's shown. I don't like that analogy, but it's pretty common. So we're selecting everything from this join, right? So that means it's going to be both of all the columns from here and all the columns from the orders details. We're going to take order details, join products, and then we're going to say on. So I think Jeff last time showed you can use using, but I like to be more explicit and use on. So on basically says specifically what is the column that we're going to join on. So order details dot product code. So product code is going to be the column for order details, and products dot product code is going to be the column for that. So note that these are the same ones, but they don't necessarily have to be. Okay. So that should join us together, and we should actually get a nice little data frame. There's some little extra stuff I put here because just to make it clear, if I didn't do this part, you will see that product code and product name, it'll be repeated from order details. So I'm just making it so it's a little bit easier for us to see what thing belonged to order details and what thing belonged to column, what's it called? Products. Okay. So if we look at this now, you can see that's why I have that O dot saying, okay, this is all the stuff from the order details, right? And you can see here, this is the end of it. So got everything to the left, right? All that stuff. And we can see the product code here. And we can see the product code matches on this side. So you can actually see that what these parts look like, the product code, the product name, and all this information. Okay, so we should expect if all the products do exist in the order, like every order detail actually has a product that does exist in the products table, we should see the same number of orders, right? So if you remember, I think it was 2,996. So we should hopefully see that same number. And we see 2,996, okay? And so that means all the orders that we had included, they're included over. So this is a good check for us to just double check that we got all the information in there. If it was less, we might have to say, wait, why was it less? And you have to look back at our join and say, oh, we might have missed this information. We have to do a different kind of join. So let's try to do a left join now. So this is going to be kind of similar, but instead we're going to do products and then see what orders were made for those products. Okay. So in this case, if I did a join the other direction, right? If I just got, if I did a join, it wouldn't include every product, right? We would only get order details, right? We would miss some information. So in this case, I actually want to just do a left join and say, okay, include everything left, right? So include everything from product, from products, but then go ahead and join the rest from order details. So that means even if there isn't an order for that specific product, still include it in our results. So basically we're going to be looking at this specifically, saying keep this stuff, you know, and we want to make sure we show every single product. Okay. You can see we still use product code, product code as our joining part. Okay. And you can see our head. And you can see here, we get our product code, right? You can see each part. And then to the right should be our order details. So you see all the different order details. And let's see if I can quickly find, let's see if I just do like 15. See if we find anything that doesn't have an order. I think we might. No, it looks like everything has an order. But we can do some quick describe just to kind of check out what this detail looks like. So note that we have 2,997 values on here. And this might happen where basically you have for each product is that there might also be a repeat within the order itself. So notice like, wait, what happened is there, there might be an extra part. So you'd have to make sure that you would look at this directly and say that they combine this in the correct way. And what likely happened is that there's an order that has 2 different products in it. So you might have to consider those parts. Okay. So I kind of asked this question, what if there are no orders for the product, right? So if basically there was never an order for that specific product, what happens, right? So if I do this guy, so note that I'm basically just saying what parts are missing. And you can see, hey, check this out. There's no order here. Okay, so remember I kind of came up with a scenario is that maybe there's a product that does not actually, it was never ordered. That's what this is right here. It's basically, this does not exist. And this is our additional one right here. It's because remember, we're combining it from the products, but then with order details. But we're saying include every product, even if it wasn't ordered. So we get all the orders and one extra one that basically was not included in the orders. Okay, so we can actually see if this is the right, does this product show up in the last join? So you can see, does this actually show up in this last part right here? And you can see here, it doesn't actually show up at all. So it's like, okay, that's an important aspect that you have to keep in mind. So again, you can see here is that if I did a mask, well, I'm just kind of reiterating is that it didn't show up within those actual order details. So that means if I go all the way back to this one up here, it was basically missing because it just was never ordered. Okay. Any questions on how these joins kind of go between like inner join and left join, what those differences are?
Wait, so sorry, the last row, you added that extra one to the first.
Mm-hmm. Yeah, that's right. This is an additional row that was not included in that very first query when we joined them.
Yeah, so that last line adds it to it.
Mm-hmm. And that's how we have that additional one. Cool. All right, thanks. Any other questions? Any clarifications? Okay, thumbs up sound good. Sideways like, sound okay. I see mostly thumbs up and maybe some smiles. Like, maybe. Okay, so last part, some aggregations, right? So again, kind of showing a little bit like what we do with pandas. They're both legitimate ways. They just have some pros and cons, right? So with pandas right here, I'm doing a df join. I'm doing a group by. So note that this is actually, pandas uses a lot of the terminology that was coming from SQL, which is kind of nice if you go back and forth. So I can have this product order details. I can group it by product code. Group it by product code, yeah. And then I'm just going to get just the product name. And then I'm going to count those parts and then sort those values. So this will show me basically every product. And it'll show me how many times it showed up in the product details. So you can see this was ordered 24 times, 25 times, and so on. Okay, 53 times. So you can kind of see like okay, this is different parts. And if you were to sum this up, you should hopefully get 2,996, right? So that's how many orders there are. So that's our, yeah, that's right. Because I'm basically getting just how many times it occurs, not how many were ordered, just saying how many times was it actually ordered versus how many products were, yeah, you guys get it. Okay. All right, so note the same aggregation. So doing this part, it's kind of similar. So we can see here, we're gonna get the product, oops, there we go. So I actually did the product code, right? So you can see that's what we're getting, product code itself. Okay, we're doing a count. So we're gonna group it by the product code. Okay, we're seeing how many times this code actually occurs.
You actually, yeah. Okay.
Thank you. Yeah, I realized it dragged it over. Okay, so we have the product code. We're gonna group it by product codes, basically saying, all right, which groups there are. We're gonna order by product count, just like we did sort values here. And then we did the normal join where we join products with order details. So we're only looking at detail or order details. So like how many of those times those were ordered. And if I run this now, I'll get a df and I should get something very similar to this guy. And you can see scrolling to the bottom, 53, and then very top should be 24. Okay, cool. Any questions on how this function or how this query runs, or what's going on this guy?
Why is it P product code as P product code?
Oh, this one right here? Yeah, if I took this out, good question. So let's say I go, this is why I put, you'll see me put commas in front of parts because this is a comment, right? So it's gonna ignore everything to the right, but I still need a comma. And so if I do this guy, you'll see that it'll just show product count. I'm just emphasizing that it's from P. So that's the only reason why I put it on there. You don't need it on there. So if I run this now, you'll see if this product count, if I run this now, you'll see P dot product code. Okay. I could have left it out. I just want to make it emphasize this part. Mostly, to be quite honest, the reason why I do this is because I'm used to seeing this output from SQL. So that's probably why I put it that way. Cool. But I could put whatever I want. I could put a flippy flop. My go-to random word that's anything. Okay, so sound pretty good? Cool. All right, any other questions? Yeah. All right.
So,
oh yeah,
sorry.
Go ahead. No, you're fine.
The last line with the data frame equals data frame underscore SQL query, that's because you set up a function earlier for that.
That's right, yeah. This function comes up way before, so I don't have to keep going cursor.execute and get the columns and all that junk. I'm just going to use this because it's easy. Again, you should be careful about doing a query directly into a data frame. You really should do a query, check the query's results if that's enough, right? Or at least limit it and then import it into your data frame. That way you can make sure you don't accidentally you run this and you're like, your computer starts like hanging. You're like, oops, I broke my computer. I got to go ahead and restart the kernel. You didn't really break it. You just kind of froze it, which again, the more you try things out, the more you'll probably break things. And then you get used to saying, I break things. That's okay. I can fix it later. But you want to avoid it because it wastes time. Okay, cool. All right, so last part, which is something I just kind of put together. So kind of forgive me if it's a little clunky, but this advanced part. So this is a little bit some stuff that's not quite in the curriculum, but I think it's kind of important, like kind of useful things. So the first part, I'm going to go ahead and close these guys so I don't have to go back and forth. All right, so first thing is basically getting that data. Same database that we just saw with the order details and product codes, okay? And so I'm going to actually create my own little set of functions. So this is something that you might use yourself. Like if you find yourself using the same stuff over and over again, for example, making a data frame from query, it might be nice to be able to make your own function or class. So since we already talked about object-oriented programming, you can actually see how this would be useful. So in this case, you can see I made this this file called Victor SQL functions. And if I go just to show you that it's just a file, so unselect that. Here, Victor SQL function. So if I click on this, this will open up. And basically this is some code I kind of wrote through. And you actually probably see some similar stuff. So this is the stuff I actually wrote to get the column names, get the SQL data frames, and then I also made a few extra things like make a connection and get tables. So this is something like I keep doing over and over again every single time. It might be useful for me to like package it all up so I don't have to rewrite it, recopy and paste every single time. I just have to bring this function or this file around, okay? So you can see here, I made it as a class. I just called it Victor SQL just to make it clear that it's not like something built in, right? Note that I'm just using object in here just to inherit to make sure I get anything if I want to, do any inheritance and stuff like that. You could have left this out and it would work perfectly fine, but it's best practice to keep this in here, okay? Note that I put in a init function. So have we seen a init before? Okay, cool. So just remember this is just called when I first instantiate the object. Note that I have a default database equals none. So that way, if I don't have to connect to a database right away. But if I do put a database in there, for example, I put like data.sqlite, so that's the database I'm going to connect to, it will basically go ahead and connect that, and it'll actually keep this as parameters for that specific instance. So that way I can say, okay, this specific instance is going to be, products or something like that, or like, the products database, or I might have the planets database or whatever it is I'm going to look at. And that way I can actually make different connections, different cursors, and treat this with. And then this is a new function that we really haven't seen. Basically, I just reiterated this get tables, basically return the tables. So note this is select name from SQLite master where type table. I have to look this up like every single time. I cannot remember it for the life of me. So this is why I put it in the function, because I can't remember it, right? Which is good, because then I don't have to think about it. And you can see here, basically, I have this query and actually use the SQL to df function. Remember, it's part of the object itself. So it basically calls this one, which will return a nice little table of the different a data frame of the different tables. Okay, so this is really nice. And then you also see I have make a connection here, which in case I want to make a new connection to a different database, I can do that as well. So again, stuff that I don't want to write every single time because I don't want to use SQLite 3 every single time. Okay. And the rest of them, this will create columns from the query. And this will actually, using this function, will actually create a data frame from that. Okay. And note that I also check for the cursor. So if I didn't connect the cursor, I can actually put in a different one if I wanted to. So if I had multiple cursors for some other reason, I can put that in there. Okay, cool. Any questions on how this kind of set up, how it functions? It's a very basic class. You can see I try to put my doc strings. You guys should put doc strings, right? At the very least, explaining what you do. One, it helps, you know, the person, if they ever use this yourself, if I pass this to someone else, they would know the basics of what's going on. And also it helps me out. So I remember what does this function do again? These are relatively small functions, but you can imagine getting really large and being like, wait, I don't remember what I did here. So anyway, I have this guy in here. So I can go ahead and import this. And remember, I just import a package, right, as whatever I want. So I can BSF, just so I don't have to write out this huge long thing, okay? And then I'm gonna actually create an instance. In this case, I'm gonna say Victor SQL, right? I'm gonna save it as V. Again, just to emphasize, in reality, like this is a bad naming convention. I'm just kind of showing you so that way you know it's not built into SQL, right? Or Pandas or Python or whatever. So you can see here, I create a new instance which connects to the data.sql database, which again is just a file in my on my computer. This is the schema just so you can see this, check this out. And then you can see here, for example, I can get all the tables. So remember, this is going to return a data frame. So I can get v.getTables. I run this, no errors, which is good. So it should hopefully work. And then I'm just kind of doing some stuff. I'm just to kind of walk you through like a little bit what's going on in here. I'm creating just a data dictionary. So a dictionary of like, it's gonna be all the tables. I'm gonna get the table name, okay? And basically in table.name. So just to kind of show you guys, maybe this will be a little bit easier for you to see first. So this is my data frame right here. So you can see here, name is basically the name of the table, right? And then you can see the different table names. So if I want to show like, hey, let me just see really quick, let me just get a data frame. This is bad practice. I'll tell you right now is that don't do this. But I'm just kind of showing you, you know, like what this would look like. So you can get multiple data, different tables and we can check it out all together. But basically I'm going to make a query, select star from that specific table name. So for example, the first one's going to be order details, second one's going to be payments and so on. And then I'm going to say from that data, save that table name. So it'll be like order details. And that's going to point to a data frame. So that's going to be the data frame from that query. So that way I don't have to like, you know, check this out every single time. Again, this is bad practice. Don't actually do this. But this is just to kind of demonstrate what this would look like. So this basically went through all of those tables and saved all the information into a data for each its own separate data frame. So now if I want to call that specific data frame, I'm going to iterate over the data.items, which is basically this dictionary here. So that's going to be a key, comma, value, right? And what's the key in this case for my dictionary?
The table name.
Table name, good, right? So the key is going to be the table name, and then what's the actual value of whatever that key points from or points to?
Table data frame.
Yeah, it's going to be a data frame of that table, right? So you can see here, I'm just going to display the table name, and then I'm going to display the head, and then a quick describe, and then I'm going to make a new line. So this will basically print out a bunch of tables, or a bunch of data frames of those tables. So you can see here, for example, order details. This is the head of order details. And here's a quick information about it. And then I have the next part. Table name is payments. Going through that, you can see there's 273 payments. Here's a little quick head. And you can see I'm just quickly looking at the different parts. Okay, and it looks like everything is filled out except for maybe contacts. So you can see there's like nothing in contacts. Okay, and there's nothing in contacts too. So that might be something I might not want to use. This is something that's pretty common. You'll find table names, you're like, oh, cool, that's great information. And then you find out, oh, doesn't exist. Okay, cool. So for example, this might be something that you would maybe, if you want to backlog, say, hey, we do actually want, you know, to put contacts in its own table. You might use information from here and say, okay, well, we know what the emails are. We can at least put emails in for employees. Maybe that's what contacts are supposed to be. So again, this is pretty common. I can't tell you the number of times where I got really excited. I'm like, oh, sweet, this table already exists. I can just query off this. And then you find out, oh, it doesn't actually exist. So pretty common. So anyway, that's kind of quickly getting that information. I just want to show you how to make your own set of functions essentially to do that. And now we can check out some stuff about SQL itself. So execution order. So this is, I think, is really important. I think it really helps understand how SQL actually like works. So normally you would have something, I'm going to write a little like select, actually, oh, I have to think a second. There we go. Okay, so if I do something like, this is just so you guys can see it better, but if I do something like select, and then I do star from, you know, table 1, oops, come on, Victor, there we go. Table 1, table 2, right? And then we're going to do something like, you know, where table 1 dot, I don't know, column 1, it's greater than 0. Okay, so making sure I get all those parts. So this would be, for example, a SQL part. And so sometimes it's a little confusing, being like, well, okay, what parts am I getting? What am I not getting? So for example, let's say I do a select right here, and I do something like, oh, let's do a group by. So let's do group by here. And say, this is all made up stuff, right? So table 2 dot, I don't know. I'm really creative today, column 1. Okay, so I'm grouping it by this part, and I might do something like, okay, let me count table 2 dot column 2, right? So we're grouping it by table column 1. I'm just seeing how many are in there, and I'll call that as, you know, my new count. And then let's give some information like table 1 dot column 2. Okay, maybe there's some information that I want because I'm fusing it together. Let's do a join just to make that a little less confusing for you guys. Table 1 dot column 1 equals table 2 dot column 2. Look at that amazing little SQL query we got going on here. Oh, I thought it was gonna, oh, I bet this, sorry. I want to see if that's right. I thought this was supposed to, there we go. Okay, now it's all nice and highlighted. Okay, so you can see here, this is a big old query. And sometimes it's a little tough to be like, because we read top bottom, right? You're like, okay, select this stuff, and then there's this bar, this stuff down here, but you're like, wait, can I do this right here? Or for example, if I put in like on my where, let's say that like my new count. Like this. This might have issues right here because you're like, wait, but my new count exists up here. Why can't I do it right here? And there's a few reasons. So this is useful to understand the execution order. So the first thing you should know is that basically SQL uses this from part. It does this thing first. Okay. So basically it's saying, all right, from, it gets just the tables and says, all right, joins them together, does any subqueries, gets that information. Then from, it goes into where and say, okay, from all the tables I'm going to get stuff. Note that it hasn't gotten any information. It's just saying these tables are going to be used. It says, all right, from those tables where only this stuff is true. So you might have multiple things like where this and this, or where this or that, you know, something along those lines. And that will restrict what comes out from that from group of tables. Okay. And then finally we have group by, where we're essentially taking that information from those tables, grouping it together, aggregating it together, right? And then doing stuff. Having, have you guys looked at having yet? Okay, I see some nods, see people like, oh, maybe, right? Having is kind of like a where statement for group by. So it's kind of like group by this where this is true, but instead of saying where, we use having, okay? And then finally comes select. So that's after all of that is done, then you finally have select. So that's why this thing, for example, might not function because it was never defined yet. Basically, it did all of this stuff first, then it did this part. So that's why it would give you an error. Like, I don't know what my new count is because it never was defined up there. Okay. And then we have order by. Basically, we have the results already, and essentially now it's just order by or limiting this information. So note that that limit will basically restrict the amount of information that's getting passed back to me, right? Like when I ask for it, like for the results, but it's not going to slow down the information. Like if it has to do a whole bunch of calculation to get it, it's still going to do that whole calculation and then limit it. So if you have some really complicated like query here and you put limit at the very bottom, it's just going to give you back, like, let's say limit 10, it's going to give you back only 10 results, but it might do the whole calculation as if it was doing everything, right? And then it's going to give you back 10 results. Okay, so I think that's an important aspect to recall. All right, any questions on that execution order? Okay, and I think this is something that, like, I think people kind of forget about, but the biggest part just to remember is that we do from and where first, and then group by, and then select is basically done very last. Okay, cool. All right, let's see here. I think I do have to go. So the last part would be actually using subqueries itself, but we'll save that maybe another time. But I was just going to show you that you can basically pass queries within another query. So I'll upload this up onto the repo. You can check this out, play around with it. Let's talk about the curriculum, but the idea is there is that you basically can use a query to put it into another query. So this is useful when you already have, like, and I've done things where it's like 6 subqueries deep. I've seen some really beasts where people say, how many subqueries can you do? Turns out 256 subqueries is how many you can do. And somehow people still reach the limit. So I don't know. Anyway, so that's kind of like what you can do. Kind of useful to go through. You probably will do subqueries because it helps you minimize the table. Okay, cool. Any last questions before I end it here? Cool. All right, so I'll stop here.